Assalamualaikum and hi everyone. We are now in lecture 9, Data Warehouse Part 4. At the end of this lesson, you should be able to explain the multidimensional data representation and describe the OLAP operation. As we know, relational databases have been used primarily to support traditional online transaction processing or LTP systems. To provide appropriate support for OLTP system, relational DBMSs have been developed to enable the highly efficient execution of large number of relatively simple transactions. In the past few years, relational DBMS vendors have targeted the data warehousing market and have promoted their systems as tools for building data warehouses. A data warehouse stores operational data and is expected to support a wide range of queries from the relatively simple to the highly complex. There is a tool that can support more advanced queries, namely Online Analytical Processing (OLAP). OLAP is a term that describes a technology that uses a multi-dimensional view of aggregate data to provide quick access to strategic information for the purposes of advanced analysis. The ability to represent multi-dimensional views of corporate data is core requirement of building a realistic business model. Multidimensional data model supports data representation and operations for decision support processing in data warehouse. OLAP database servers use multidimensional structures to store data and relationships between data. Multidimensional structures are best visualized as cubes of data. Data cube or hypercube is multi-dimensional format consists of cells containing measures, for example sales amount, and dimensions to label numeric data. Each dimension contains values known as members. Let's take a look on the terminology of data cube. For each data cube, there are three dimensions: X, Y, and Z. Simply, we can say dimension is a subject label for a row or column. Each dimension consists of members. Member is a value of the dimension. In this example, the members of dimension X is A, B, and C. The members of dimension Y is R, S, and T. And members of dimension Z is F, G, and H. Each cell in the data cube is filled by a data which we call as fact or measure. Measure is a quantitative data stored in a cell. If the dimension chosen has weak relationships, there will be a lot of empty cells in data cube, which we call as sparsity. Now, let's take a look at this example on how to draw a data cube. The table on your screen shows the sales data in 2016. First, find a fact table or measure. As we know, fact table is something numeric. In this example, the fact or measure is the sales. Then, determine the dimension. Since it is a sales data in 2016, then Z dimension has to be 2016. For X, you can choose any descriptive data from the table. In this case, I choose product as the X and location as the Y. After you have determined the fact and dimension of X, Y, and Z, we can start analyze how many members will be in X, Y, and Z. Since we have fixed the Z member to only 2016, you need to analyze first the members of Y and X. In this case, the unique members of Y are California, Utah, Arizona, Washington, and Colorado. For unique member of X, we have monolaser, inkjet, photo, and portable. After the members of dimensions are determined, it is the time for you to find the intersection of X and Y members to store the quantitative data of sales in each cell. For example, the sales of monolaser in California is 80. So the intersection of California and monolaser should be 80. The sales of monolaser in Utah is 40. That's the intersection of Utah and monolaser. The cell will be 40. And so forth until you finish all the data inside your table. For instance, the last data in this example is portable sales in Colorado is 60. Now let's take a look at this case study for you to understand better on how to draw a data cube. You are given a data of customer, product, staff and quantity in the sales table. The question is, draw a data cube for sales done by staff 11.
As I said, the first task that you need to do is find the fact table or the measure. Okay, something numeric here is the quantity. Okay, because customer, product and staff is something descriptive. Okay, so the dimensions that we have for data cubes, okay, for data cubes, we need to have the x, y and z. So the question asks you for sales done by staff 11. What does it mean here? The z has to be staff equals to 11. Okay, then the x and y you can choose from customer or product. It is up to you. So for me, I choose the customer as my x and product as my y. Okay, so now it is a time for you to determine what's your x. Okay, so this is your customer. How many unique data that you have inside customer? 101, 102 and 103. So means you have here is the y. Okay, sorry, our y here is the product. Okay, so if you take a look here, 101, then you have 102 and another one is 103. Okay, so this is for our customer. Then for our product, we have one unique product. Find 1, 2 and 3. Then any other product here are repetitive. So means we know that we have product 1, product 2 and product 3. Okay, so now you have your the member of X and Y. Now let's take a look on oops. Let's take a look on our Z. Okay, so let's take a look on our Z. So if you take a look over here, okay, your Z over here is the staff. Okay, so you know that you have two different staff, 10 and 11. But the question one only staff 11. So what does it mean here? You have two different data on staff. Okay, but what is the data that is on the front? Okay, it should be 11. Another one is 10 because 10 is at the back. We cannot see. Okay, we cannot see the data until you do the slice operation after this. Okay, we will take a look after this. Okay, so this is for staff 11 because this part is at the front. So that's why we put 11 at the front over here. Okay, so now after you have done with your x, y and z, it is time for you to read the table to put the quantity. Okay, to put the quantity inside the cells. Okay, so if you take a look here, we want only staff 11. So this is staff 11, this is staff 11, 11 and this 11. Because staff number 10 over here, we cannot see the data. So that's why we just ignore. Okay, so if you take a look, product 101, sorry, customer 101, product 2, what is the quantity? 10. 101 to the quantity is 10. The second one that we have for data 11 is 102, 2. The data is 8. 103, 1. 103, 1. It is over here. What is the data? 50. Okay, then another one, 103, 2. 103, 2 here. So what is the data? 45. Okay, so these are the sales done by staff 11. If you want to do number 10, then of course you need to do another data cube. However, the Z over here at the front, it must be 10. Okay, then you read data for 10. Okay, so then normally the empty cells we will put as 0. Okay, the empty cells here we'll put as 0. So this is the data cube based on the question, which is the sales done by staff number 11.
OLAP tools or OLAP servers are categorized according to the architecture used to store and process multidimensional data. There are four main categories of OLAP tools, which are multidimensional OLAP, MOLAP, relational OLAP, ROLAP, hybrid OLAP, HOLAP, and desktop OLAP. These OLAP servers or OLAP tools allows managers and analysts to get an insight of the information through fast, consistent, and interactive access to information. Relational OLAP or ROLAP is the fastest growing type of OLAP tool. This growth is in response to users' demand to analyze ever increasing amount of data. ROLAP supports RDBMS products through the use of metadata layer, thus avoiding the requirement to create a static multidimensional data structure. This facilitates the creation of multiple multidimensional views of the two-dimensional relation. To improve performance, some ROLAP products have enhanced SQL engines to support the complexity of multidimensional analysis, while others recommend or require the use of highly denormalized database design such as the star schema. Multidimensional OLAP or MOLAP tools use specialized data structures and multidimensional database management systems to organize, navigate, and analyze data. To enhance query performance, the data is typically aggregated and stored according to predicted usage. MOLAP data structures use array technology and efficient storage techniques that minimize the disk space requirements through sparse data management. MOLAP tools provide excellent performance when the data is used as designed and the focus is on data for a specific decision support application. The example of multidimensional OLAP is data cube. Hybrid OLAP or HOLAP is a combination of ROLAP and MOLAP. It provides limited analysis capability either directly against RDBMS products or by using an intermediate MOLAP server. HOLAP tools deliver selected data directly from the DBMS or via a MOLAP server to the desktop or local server in the form of data cube, where it is stored, analyzed, and maintained locally. Vendors promote this technology as being relatively simple to install and administer with reduced cost and maintenance. The advantage of HOLAP server is it offers higher scalability of ROLAP and faster computation of MOLAP. Now, let's move on to OLAP operation. There are 5 OLAP operations that you need to know. The first one is slice. Slice is a focused attention on a subset of dimension. It replaces a dimension with a single member value or with a summary of its measure values. For dice, it focuses attention on a subset of member values. It replaces a dimension with a subset of members. For drill down, it obtains more detail about a dimension. It navigates from a more general level to a more specific level. For roll up, it summarizes details about a dimension. It navigates from a more specific level to a more general level. The last one is pivot. It presents data in different order. We rearrange the dimension in a data cube. All of this OLAP operation is only works on the data cube. Let's take a look on the example of each and every OLAP operation.
So now let's say we have this data. So now let's say we have this data. Let's take a look on the OLAP operation. Let's say we have this data. We have state, Melaka, Selangor, and Pahang. And we have car brand, Produa, Proton, and others. And the Z is our year, 2019 and 2020. So if we take a look based on this data, okay, based on this data, this is the sales of car brand according to states in 2019, because as I said, for 2020, the data is behind here. We cannot see. Okay, so how to see the data for 2020? You can do slice operation. Okay, so means you do the slice operation. So what is slice operation? This focus attention on a subset of dimension. So based on our data cube, so what are our dimensions? We have x, y, and z. Okay, so when we do the slice, we only take the x and y. So means you cut, okay, you cut the data over here. Just like your, remember we have the banana cake, something like this, and so your mother cut it like this. Okay, slice per slice. Okay, so by right, this is what we are going to do. Okay, so if you want to see data in 2020, you slice the 2019, you will see data for 2020 over here. So when we have the slice, so what is the result? As I said, we will have only x and y. So if we slice this data cube, this is what we will get. Melaka, Selangor. Okay, you have the x and y, so you need to label the x and y. Selangor Pahang, this is Puro 2, Proton, and also others. Okay, we don't have the Z anymore because if you have the Z, it is still a data cube. So when we do the slice, focus attention on subset, we take the subset of X and Y only, then put the data back. Okay, 400, 7,200, 600, 300, 6,800, 700, 4,000, and 3,500. So this is the slice operations. Okay, you have only the X and Y. Okay, the second one we have the dice. Okay, the second one we have the dice. So what is the dice? Focus attention. Okay, focus attention on a subset of member value. Subset of member value. So who are the members? So based on this data, okay, who are the members? Based on this data, the members are Melaka, Selangor, Pahang, Puro 2, Proton, and others. So these are the members of the dimension. So what if I said I want to see the sales of Puro 2? So means what do we need to do? Okay, if I said dice the data so that I can see the sales of Puro 2. So if we dice of Puro 2, this is Puro 2, and if we dice, we will have this one. You can dice horizontally or vertical. Okay, vertically. So it's up to you. Okay, it's up to depends on the question. Okay, so we have 1,200, 600, 700. So this is Puro 2. So you still have Melaka, Selangor, and Pahang over here. Okay, so this is the dice of Puro 2. So what if I said dice the sales in Selangor? Okay, dice the sales in Selangor. So where is Selangor? Selangor is here. So if you dice Selangor, this is what you will have. Selangor, then what is the data? 600, 300, or 6,800. Label the data Puro 2, Proton, and others. Okay, so means dice subset of member. So what is the member? Maybe Selangor, Melaka, or Pahang, or Puro 2, Proton, or others. Okay, so you focus on the member of the dimension. Okay, so now let's take a look on drill down and roll up. Okay, drill down and roll up. Drill down means you want to obtain more detailed data, while if we roll up, we want to summarize the data. Okay, so if you drill down, you need to find general to specific. So what if I said drill down the sales in Melaka? Okay, so if we have this Melaka, okay, if the sales is 1,200, so if we drill down in Melaka, so the city that we have in Melaka, maybe we have Jasin, let's say we have Alor Gajah, and also Bandar Melaka. Okay, so let's say we have these three different branches in Melaka. So if we drill down, maybe the sales in Jasin 500, the sales in Alor Gajah is 200, and the sales in Bandar Melaka is 500. So means you go down from general to specific. Okay, so we know that the sales is Melaka in 1200. So if we drill down the sales in Melaka, we will have in Jasin actually the car that is sold for Pro 2 is 1200. In Jasin 500, in Alor Gajah 200, and in Bandar Melaka 500. So what if I said roll up the sales in Melaka? So if we roll up the sales in Melaka, it will go from specific to general. So in Melaka, 500 plus 200 plus 500, we will get 1200. Okay, so that's the meaning of roll up, means you summarize the data. So in Melaka, we have 3 branches. So if we combine all the sales in all the branches in Jasin, Alor Gajah, and Bandar Melaka, then we have 1200. And this one indicates that this is for sales in Melaka. So means you roll up from specific to general. Okay. Then the last one is pivot. Okay, the last one is pivot. What does it by pivot here? You present data in different order. Okay, present data in different order. So means now you can change the axis of dimensions. Okay, so that's why sometimes maybe what you want to do is the car brand is on the Y. Okay, car brand is on the Y over here. The states is in the X. Okay, so we still have almost the same data, however it will be in different order. Okay, because if you take a look, just take a look at the Rubik cube that you have. Okay, so you can change the position of the Rubik cube, isn't it? So same goes with this one. So if you change the axis, then of course the car brand here will be Pro 2, this is Proton, and this is others. And this one maybe you want to do Melaka. This is Pahang. This is Selangor. So of course the data inside the cell will be different. Okay, so in Melaka Pro 2 is 1200. Okay, in Pahang Pro 2 is 700. Okay, for Selangor Pro 2 is 600. So see, just now you have something like this. Now since you change the order, it will be a little bit different. Okay, so that's what we call as pivot. So sometimes maybe you want to make your x as the year. Okay, this one you have the states. Okay, as your x. And how about your z? Okay, your z is the car brand. Okay, you have 3 different car brands. So maybe you will see car brand for only this is 2019, this is 2020. So since you need to have another data lah from the table to fill up all the details. So that's why pivot means you can rearrange the order of the dimension inside your data cube. Okay, so the axis can be changed according to what do you want to see. Because just remember your data cube, it is a data cube, and you can change the position of which one is X, which one is Y, and which one is Z, and so forth. Okay, so that's what we call as pivot. So you arrange the dimension in data cube.
So that marks the end of our syllabus. Thank you and Assalamualaikum.